A message just arrived from 10 to the power of 120 years in the future. Not from another star. Not from another galaxy. From the end of time itself. How is that even possible? And what happens if we answer? Deep under mountains and ice, we built the quietest ears in history. Detectors that wait in the dark for neutrinos, ghost particles that pass through light years of lead without stopping. They ignore dust, ignore magnetic fields, and fly straight from the hearts of stars. Perfect messengers, if you can ever catch one. For years the data was boring. Solar neutrinos. Random background. An occasional distant supernova. Then, one morning, it changed. A run from 3 nights earlier showed something impossible. Neutrinos from every direction at once, all in a narrow energy band, spaced in time like a metronome. Maya Chen stared at the plot. I've triple-checked. That pattern shouldn't exist. When they graphed the arrival times, they saw prime numbers. Not random. Not natural. They called in Elias Kwan, a quantum information theorist. He assumed the signal was a code, because that's what he used to design. Error-correcting codes, the kind you use when you care about every single bit. If I were designing a message to cross cosmic distances, or cosmic time, I'd build redundancy into every level, he said. Error correction with an error correction. Aisha Rahman folded her arms. And that's exactly what this is, Elias replied, eyes bright. Within hours he found layers. A base pattern of primes. A frame structure with checksums. And a header that looked like cosmology. Densities of matter. Dark energy fraction. The Hubble constant. Numbers that describe our universe. Then came the timestamp. Not in years. In scale factor. How big the universe is compared to now. Converted, it mapped to an era when stars are gone, black holes evaporated, everything near heat death. Aisha whispered, that's trillions of trillions of trillions of years away. Either we're wrong, Elias said, throat tight, or someone at the end of time just sent us a message. Aisha stared at the number until it blurred. This wasn't just an alien signal. It was a violation of causality. That night, she couldn't sleep. She stood at her apartment window, city lights dulling the stars. What are you trying to tell us? She murmured to the glass. The discovery couldn't stay secret. Neutrino observatories in Antarctica, Japan, and Canada all saw the same pattern. Dr. Mara Okafor, head of the Global Astrophysics Council, convened an emergency meeting. What we say here doesn't leave this room, she told the assembled scientists and officials. Not until we know if physics just change. She formed a small team. Aisha, Elias, and a few others. Decode. Verify. Try not to break civilization. They started with the big question. How can anything talk from the end of time? Elias pulled up an animation of an expanding balloon dotted with galaxies. We all know about black hole event horizons, he said. Points of no return. But the accelerating expansion of the universe creates a similar boundary around us. Because of that expansion, there are regions whose light will never reach us, no matter how long we wait. That's a cosmological event horizon. And in some theories, what happens at the far future, edge, can act like a boundary condition, a final frame influencing which paths through the cosmic story are allowed. Most physicists treated that as philosophy. Someone far ahead had turned it into engineering. The neutrino stream continued. Tiny bursts, every few hours. Bit by bit, a file assembled. First came history. Early universe maps, element abundances, galaxy formation curves. All matching our observations up to about 50 billion years ahead. Then the script changed. In their timeline, humanity, or its descendants, survived star death. They built Dyson swarms around red and brown dwarfs, swarms of collectors sipping every remaining photon. They learned black hole mining, feeding matter into spinning black holes and stealing energy from their rotation. They moved their minds into reversible computers, machines that almost never erase bits, and so waste almost no energy. Every time a conventional computer erases a bit of information, it generates heat, Elias explained to Mara. Landauer's principle. But if computation never erases, only rearranges, the energy cost can get arbitrarily small. In a cold, empty universe where every joule matters, Mara said slowly, that's not just efficient, that's survival. At near absolute zero, in a universe almost empty, they stretched finite energy into almost infinite thinking time. They called this era the long now. Outside, the universe cooled toward darkness. Inside small, dense structures of matter and computation, light and patterns continued. But even that couldn't last forever. When the last black holes evaporated, there would be no more gradients, no more free energy. Just a thin soup of low-energy particles and quantum fluctuations. The long now had a problem. Go quietly, or try one last, insane trick. Elias found that trick in the math. In quantum mechanics, there's this weird thing called post-selection, he told the team, drawing quantum circuits. You run an experiment, but only look at the subset where a specific outcome happened at the end. Like rolling dice until you get double sixes? Maya asked. Sort of. The math gets strange. It can look like later measurements are influencing earlier ones, though you can't use it to send signals backward in time. Some theorists had toyed with the idea that the universe's final state could act like a giant post-selection. Conditioned on a particular future existing, certain histories would be more likely. In the far future, they had taken that idea literally. They couldn't send photons back. Not gravitational waves. Nothing that carries normal information. But they could subtly bias vacuum fluctuations and neutrino phases along their entire past light cone, by conditioning their entire civilization's configuration on a specific history. They essentially said, we will only exist in timelines where, in the past, a certain neutrino pattern appears. In those timelines, that pattern must be there, by definition. The neutrino message was that pattern. It wasn't blasted back in time. It was woven into our universe's probabilities from the start, only noticeable now because our detectors are finally good enough. It sounded like magic. It checked out like math. Then came the line no one expected. The senders weren't aliens. They were post-humans. Our own descendants, trillions of generations ahead. Now the question shifted. Not, who sent this? But, what do they want? After history came instructions. A device. Not a time machine, exactly. More like a boundary anchor. Elias called it the Omega Mirror. Built from materials we already knew in theory, topological insulators, superconducting metamaterials, vast qubit arrays. Launched far from Earth, cooled to microkelvin, shielded from all noise. Its job was to run massive, carefully designed, post-selected quantum experiments. To amplify the very correlations the long now civilization had already exploited. Plain language? It would make their timeline more probable, at the cost of making other possible futures less likely. If we build this, Mara said, staring at the glowing schematic, we're not just helping them, we're choosing their universe. A future where intelligence survives star death, huddled in reversible computers until almost the end. A future where their message exists. And if we don't build it, a universe where they never arise at all. Buried deep in the code were constraints. Their own existence was tied to this device being constructed around our cosmic era. No Omega Mirror, no long now. No paradox. No time police. Just branches where they never were. From their side, the message was an invitation. From ours, it felt like a demand written into the laws of physics. The team fractured. A universe where minds could sculpt their own past felt wrong to Aisha. But letting all of that just dissolve into noise felt worse. Elias saw another layer. Inside the Omega Mirror plans were optimizations for quantum tech we're building now. Use them early, and humanity leaps decades ahead. Maybe more. He realized the loop. We build the mirror because they tell us how. They can tell us how because we built it. Mara voiced the darkest thought. What if their endless life is a cage? She asked. A hyper-optimized existence with no room for waste. For wandering. For art. Say yes, and you lock one branch of the universe into a single, austere destiny. Say no, and that branch vanishes quietly from the space of possibilities. The last part of the message wasn't math. It was voices. Snatches of conversation. Laughter. Someone reciting an ancient poem. Then text. We are not asking you to save us. We exist only in paths where you choose this. If you do nothing, stars still burn. Life may bloom elsewhere. It will end in silence either way. If you build the mirror, there will be a branch where we remember you. Where your names are seeds in our archives. Where consciousness rides out the cooling of the stars. The end of time is only an end for those who do not prepare. For us, it is an asymptote. We approach stillness but never reach it from inside. They weren't begging. They were making an offer. Our messy, branching future in exchange for one very long, very narrow path. The news leaked. Of course it did. Some called the Omega Mirror a new Tower of Babel. Others said we had a duty to let intelligence outrun entropy. Poles split. Nations argued. Religions reinterpreted. Conspiracy threads went wild. Meanwhile, deep under rock and ice, the neutrino pattern faded. No new data. No updates. Just silence. They had said their piece. The choice was ours. Aisha stood alone in the observatory one night, the lab quiet, stars invisible overhead. Maya's voice broke the silence. What do you think we'll do? Aisha watched the simulation of branching timelines, one glowing brighter than the rest. I think, she said, whichever branch we're in, someone will think they chose right. We don't know, in this story, what humanity chose. Maybe the Omega Mirror is already being assembled in orbit, disguised as ordinary satellites. Maybe it was rejected as too dangerous, lost in committees and public outrage. From inside time, we can't see the branches splitting. We only know this. A message arrived from the end of time. It wasn't a warning. It wasn't a prophecy. It was a question, written in neutrinos and math, flung along the only paths physics allowed. And like all the hardest questions, the universe refused to answer it for us. If you could choose that future, would you?